I haven't, it's like, it makes so much money, it's not even worth for them to send me a check because a stem costs more than, I have 14 views. Stem's gonna cost them more money than send me a check. Um, so I probably generate 0.0001 cents. And stems 42 cents, 43 cents. All right, let's talk about how to graph a rational function. Graph a rational function has a lot of things that you have to determine. So I'm gonna pick a f of x is equal to 3x squared over x squared minus 4. And I'm gonna pick this function. I'm gonna say, let's try to graph this as much as I can. But first thing, let's figure out what will be the steps. Steps that you have to go through to graph a rational function. First thing is determine the domain. Okay, determine the domain, which is a denominator. That denominator cannot equal to 0, right? If you set denominator cannot equal to 0, you can solve for it. Second, you can figure out, are they determine the symmetries. How do you determine symmetry again? We already know this. Not negative b over 2a, that's for quadratic. But how do we determine the symmetry? No. Yes, Anna? Huh? No, that's, you were thinking about quadratic. How do we determine the symmetries in terms of precalc? We talk about this. There's some type of function versus some type of function. Thank you, Landon. Odd and even function. So you can plug in negative x and you go back to original. What is that called? Even functions, right? And what does the even function have symmetry of? Symmetry to y-axis. Good. Does that make sense? If I plug in negative x and you got opposite the original function, then that's called odd functions. And this is going to be symmetry to x-axis. Is that okay? Plug in negative x. See what happened. Now, one of the first thing is make sure you factor everything. Okay, so one of the, you want to make sure it's factor everything. So factor the rational function. Because once you factor it, you might find the whole. Remember, you have a cancel factor equal to 0. If you set cancel equal to factor equal to 0, if you solve for it, and then factor a rational function and simplify to get a new equation. We did that on the new equation. We're gonna talk about that new equation last time. We did that yesterday, I think. We simplified that x minus 2, we cross it out, and we set that x equal to 2 and becomes the whole, right? So cancel factor is the whole, or also known as math, it's called removable discontinuity. Removable discontinuity. You set a cancel factor equal to 0, and that's going to be the whole. Now, if you want to find the coordinate of a whole, you solve for x. You take this, solve for x. You take this, solve for x, and plug in the new equation. Plug in to new equation. We did that yesterday. If you look at the notes or look at everything, plug in a new equation. So you can determine the domain, you can determine the symmetry, you can factor the rational function and simplify it. 4. Determine x-intercept. How do you find one x-intercept? set y equal to 0 and solve. Remember, you are solving for numerator. Solve the numerator equal to 0. Why is the numerator? Because denominator of 0 is actually undefined. Only the numerator matter in this case. Fifth, how do you determine y-intercept? How do you determine y-intercept? Set x equal to 0. How do you determine vertical asymptote? How do you determine vertical asymptote? Set denominator equal to 0. And solve for x. 7. How do you determine horizontal asymptote? Compare the degrees, right? Compare. So compare the degrees of numerator versus denominator. Now I'll give you an example. If you have 3x squared plus 2x and 4x squared plus 3x, what is the horizontal asymptote? What is the horizontal asymptote?
3 over 4.
Y equal to 3 over 4 because they have the same degrees, right? What if you have 3x squared plus 4x over 6x cubed plus 3x? So what is the horizontal asymptote here?
0.
Because the numerator has one lesser degree, it's going to be y equal to 0. Now, do you have any horizontal asymptote here? Do you have? No. So this is non-horizontal asymptote. However, that lead to the next topic. It lead to this is a slant asymptote. If the numerator has 1 degree larger, it's going to be slant. And the way to determine a slant asymptote is to do long division. So there's a lot of things happening here. Long division. And then we're going to graph. Okay. So let's review everything. You can determine the domain by set a denominator can equal to 0. You can find out what domain can equal to. You can determine the symmetry by plugging negative x, see what happened. You can factor out as much as you can. You can find like a lot of things. If something is canceling, guess what? That is going to be your slant asymptote. I mean, sorry, you're going to be a whole. You can determine x-intercept by setting the numerator equal to 0 on the function. Y-intercept is plug in x for 0. Vertical asymptote is going to be set denominator, solve for x. Horizontal asymptote, compare the degrees. So this is all about yesterday's homework. So now we're going to do a comparison. Now we're going to do this function. We're going to say 3x squared over x squared minus 4. Okay? So let's first thing first. What is the domain of this function? Very easy to determine domain. Yeah, so probably the first thing I would do is I will graph, I will factor everything. So x plus 2 and x minus 2. Does that make sense? And then that's going to be x plus 2 and x minus 2 cannot equal to 0. So x cannot equal to 2 and x cannot equal to negative 2. So it'll be negative infinity to negative 2, union from negative 2 to 2, union from 2 to infinity. That's the first thing. So I know all this part, it doesn't have a graph at 2 and -2. The second one is determine symmetry, right? Somebody look at what is symmetry here? Okay, so what do? We'll plug in -x where it has x. So that's going to be 3 times -x squared over -x to the square minus 4. So that's going to be 3x squared over x squared minus 4. What kind of symmetry is this? That's not a symmetry. Even function is not a symmetry, but even function causes some type of symmetry.
Y.
So this is symmetry to y-axis. Is that okay? We're good? What's the next thing we want to determine? The next thing you want to determine. Huh? Yeah, we factor already, so we factor it. Do you see any canceling factor? So no cancel factor. So that means no whole, right? There's no such a thing as whole. 4. What is the x-intercept and y-intercept? Is the next thing to find the x-intercept, y-intercept? What is the x-intercept here? What? 2, you actually don't have value. You actually have vertical asymptote. What? How do I find x-intercept? What? Yeah, just plug in, just set the numerator equal to 0. So again, it's a coordinate, please. Please don't write down 0. I don't know what is the 0. Is it 0, comma 0? This is the x-intercept. And the y-intercept is going to be the same. So f of x, in this case, is going to be the same because we plug in 0 for 4, -4, so it's 0. So 0, 0, 0, 0 is both x-intercept and y-intercept. So we have one x-intercept and y-intercept. How many vertical asymptote? What is it? 2. X equal to what? X equal to 2 and x equal to -2. X equal to something. This is not a coordinate, it's an asymptote. What is the horizontal asymptote? Y equal to what? Why is y equal to 3?
3x over 3x squared over x squared.
Yep, so 3 over 1, right? But they have 7 degrees, so my horizontal asymptote is y equal to 3. Now, here's the thing. We have all this information. A lot of people are afraid to graph. But even if you're afraid to graph, you should find all this information first. Because all this information, each information you find is worth a check mark. Now, to graph, you have to be fearless. Just go ahead and graph. You graph completely wrong and just go back to find out what you did wrong. Go back and find out what you did wrong. So we're going to graph this function. First of all, I like to graph a lot of vertical asymptote just because I think vertical asymptote is the easiest one to graph. And the vertical asymptote, I'm going to graph something like 2 and -2. So I'm going to go with here. This is -1, this is -2, this is 1, this is 2. So I'm going to draw the dotted line here. Because if you graph in the vertical asymptote, you know that they cannot cross this line. And not only they cannot cross the line, if you any graph going toward this, it's going to go either positive direction or go to negative direction because they are like a strong current, right? If you go in here, it's going to go up like this. If you go in this way, it's going to go down like this. Does that make sense? You either go like this or like this on term of this. And we'll talk about that in a second. Is that okay so far? Actually, let me draw it a little bit thicker here. So this is this. Question about this. Where's the horizontal asymptote? 3, right? Y equal to 3. So don't tell me just 3, is y equal to 3. So y equal to 3 is going to give me this. Are you following me so far? Is any x-intercept here? A y-intercept? 0, 0. So 0, 0 is this is a graph. What else I can find? No hole, there's symmetry to y-axis and everything. Is this okay? Now you say, hey, I want to figure out how do they behave right next to asymptote. Let's go to the left side of this function. Let's go from approach from. So the idea is you might possibly get this because that's the asymptote. Sorry. You're going to get possibly like this because they all float toward the asymptote or this. Does that make sense? Either you get one or another. You get one or the other. But you're not going to get both because that's not a function. So you're going to get one or the other, and you're going to figure out which one is which. Is that okay? So what happened is I'm going to take a small value that is less than -2. And usually prefer is 0.1 away. I'm going to say that again, 0.1 away. So what's the value that less than -2 but is 0.1 away? What? What'd you say? Say it louder. -3 is not 0.1 away. -2.1. Okay, so what I'm going to do is I'm going to plug in -2.1 here. So 3 times -2.1 square, right? And 2.1 negative plus 2. And -2.1 minus 2. And I'm going to drag this on the bottom. Okay, I don't really care about what value is. I just care about what sign is. What do you think the sign on the top is going to be? Something negative square times 3. Is that positive or negative? Positive. Good. Is that okay? I don't need to care about value. And what happened is -2.1 plus 2 times -1 minus 2. Is that going to be positive or negative? It's going to be what? It's negative times negative, right? So it'd be positive over positive, so it's positive, right? So we know that on this side, either go in here or go in here. Which one's a better option? It's going to go up. So the graph is going to go this way. We know it's not going to go down because we're going to, the vertical asymptote is going to go toward the asymptote. Either it's going to go up or go down. But on the left side, you're not going to pass this line because there is horizontal asymptote. Horizontal asymptote is going to go toward this way. Is that okay? Okay, yes.
Which trait it goes through?
What do you mean? Like
When it's like for example, that would be like on -4 x value, x, y.
-4, so -4 is roughly right here. It's going to be above this asymptote because it's going to go toward the asymptote. It's not going to go across the asymptote. In generally speaking, they don't go across the asymptote, except horizontal, by the way. but that's gonna be the different case. But vertical is never, and horizontal, especially toward the end, is always plateau like this. So either have option like going like this or like this, but which specific point can it be like this? Yeah, they all represent the same thing because I don't know what exact value because I'm not gonna plug in every single value there is. But I can give you a general logistic of the graph. We know it's either this way or this way, but now we know it's going to the top because we plug in some value that is very close to the asymptote. If it's a positive, it's gonna go toward the top. If it's negative, it's gonna go to the bottom. Is that okay? So can you figure out what happened? Is this one this way or this one this way? Can you figure out by plugging a value that is very close to -2, but on the right side of -2? -1.9, it's good. Can you tell me that what is the resulting sign is going to be if I do -1.9? So let's just say 3 times -1.9 squared over -1.9 plus 2 over -1.9 minus 2. Okay, think about it. Think about what's the sum up sign to be. Huh? What do you think? Is it positive or negative? The bottom is what? The top is positive. The bottom is positive times negative, right? So it's going to be positive over negative, so it's negative, right? So we know that this side is going to go toward negative version of this graph. Now, here's what the cool thing is. I don't need to do it to the other side. Why? Because of symmetry, right? Symmetry is like a mirror to y-axis. That almost you get this, you are gray. And this is what a graph is going to be. Because you know how to determine one side, the other side is going to be exact symmetry. Now that's why I determined symmetry first, because I might have to save half the work, because I didn't really want to plug in, let's say 1.9 into the function and do it over again, and plug in 2.9 to the function and do it over again, even though it's going to exactly the same thing. Got it? And there you go, there's a graph. So let's check whether this graph's true or not. What is it? 3x squared, right? Over what? And that's this, and you're like, oh, okay, that doesn't make sense. But now it makes sense. Now I'm gonna say x equal to -2. And if I click long enough like this on the blue dot here, you can actually create a symmetry like this. So every time you do your homework, check your answer, see if it's right. And graph in the x equal to -2. And graph in the x equal to +2. And click longer, and they will drag down to be dotted line. So you see those two asymptotes. What's the last asymptote? Y equal to 2. Y equal to 3, sorry. And if I click long enough, boom, oops. Y equal to 3, right? And that's dotted line. And there you go. Just follow exactly what we predicted. We just need to know how do they behave next to the asymptote, especially next to the vertical asymptote. If we figure out how they behave next to the vertical asymptote, you can figure out what happened. Now, I take a long time to do this. Problem is I just want you to start slowly figure out what happened, and then go through that. Yes.
If you had used +2 instead of -2, would you still get the same answers?
What do you mean negative 2.1, or
like if you had done
2.1?
Yeah.
Yeah, you will get roughly the same answer, because if I were to plug in 2.1, so it'd be 3 times 2.1, right? Square, that's going to be positive. 2.1 plus 2, is that negative or positive? Positive, right? 2.1 minus 2, that's going to be positive. So it'd be positive over positive over positive, right? It's positive. So 2.1 is this way, right? 2.1 is on the left side of this. See, it's going to positive. Now, in this case, it's the same, but whatever symmetry of the origin, then that's actually going to go down. But you're going to verify by plugging the number that's close to it. Does that make sense?
Can you find how sharp the curve?
That's no one can find out. Decibel can find out how sharp the curve is, because we don't have the extra things to figure out every single point and can possibly figure out. We only have certain tools with our Decibel's calculator. We only have certain tools to figure out what is it. It's not possible to figure out that perspective. Is that okay? Okay, so I'm gonna ask you to do a simple one, not gonna be complex. So so this is the figure out, this is the f of x here. Wait, hold on a second, can somebody answer the phone?
Yeah. Just,
So x plus 3 over x squared plus x minus 6. Yeah, I changed it to 3, so.
asking if it's okay to pay for your shirts.
Yeah, it's okay.
He said yeah.
Oh, not pay me, but you had to pay for the club fee. That's okay. They will come talk to me. I don't want money. So this is x plus 3 here. So make sure that this is x plus 3, because the reason why I make sure that this is plus 3, because that is something else. But you can find a location that that's something else too, whatever that. I'll check your decimals. I'm a reminder, this one has a hole. Did you find a hole? Now you gotta find the location of the hole. You gotta draw it in the graph. Okay, find out location by plugging a new equation. You'll figure out a y value. Then you can check your answers. Diego, why comment on my chat? Huh? It says Diego Aguirre. You know? Why don't you put a donation while I